In this video, what we're going to do is pick up from our previous video where we ended up with our correlation matrix. And so if we use Microsoft Excel, what the data analysis feature will not provide is the statistical significance level for each of these correlation coefficients. So those would have to be computed manually in Microsoft Excel. So we're not going to do that here in this video. So we're just going to jump right over to the multiple correlation, or I'm sorry, the multiple regression analysis. So I'm just going to give this sheet a label at the very bottom, and I'm just going to type in correlation and hit enter. So now I'm going to go back to my raw data, and as you can see here, we have 50 states with varying levels along our 4 variables, with items C, D, and E as our predictor variables for our outcome of life expectancy. So the first thing I'm going to do here is I'm going to conduct a regression analysis, but I'm only going to include 2 variables. I'm going to include life expectancy, and I'm going to include high school graduation. I'm just going to ignore income and murder rates. So I'm going to go back to the data feature. So this would be a single predictor regression. I'm going to click data analysis, and I don't want correlation. I'm going to move down until I find regression. And now here I have to identify my criterion variable, and the outcome variable is the Y range. So automatically I see that the cursor is blinking in this box. So that means I can go over to the worksheet, grab life expectancy, make sure you take the label as well, and we'll click the labels box as well. Now for the X range for our predictor, as I indicated, I'm only going to do one predictor in this analysis. So I need to put the cursor in the box. I come back to my sheet, and I'm going to select high school graduation. And I have all of those in. I want the confidence level as well, the 95% confidence level for the outcome of the analysis. And the Microsoft Excel will allow for the calculation of a number of other features, which includes the residuals, the standardized residuals. We're going to skip this for now and just carry out the multiple regression to generate our regression coefficients. So I'm going to hit OK. And what we're looking at here, let me just come back, and I'm going to increase this view. And I'm just going to expand these columns so we can actually read all of these items. Okay, so what we're looking at here is the outcome of our regression analysis, and in this regression analysis we only included one predictor variable. And so the items that we want to identify is the R squared value. So we see an R squared of 0.34, and that translates to the conclusion that the predictor variable, in this case high school graduation rate, accounted for 34% of the total variability in the outcome variable, which is life expectancy. So typically this is what we want to present. We need the full ANOVA table, and so what we see here with the ANOVA table, regression refers to the variability through our sum of squares due to the prediction equation. The residual, or sometimes called the error sum of squares, is the unaccounted for variability in the data, and the total is the sum of the two. So we can see here that the variability due to the prediction equation, which is a plus bx, accounts for about 34% of the total variability in the model. And our F statistic that we get from the ANOVA table tells us that this is a statistically significant predictor this being high school graduation of life expectancy. When we go to our regression table here, what we're seeing here is the y-intercept and the slope of the line. So this is our b coefficient. So if we imagine our regression equation of y equals a plus bx, the intercept here is coefficient a, high school graduation is the slope, which is coefficient b, each of which will have a standard error associated with each. And you can see that the t statistic indicates that the high school graduation rate slope is significantly greater than 0, as well as the y-intercept here, confirming the results of the ANOVA table that the high school graduation rate is a significant predictor of life expectancy. Is it a strong predictor? It accounts for less than half of the variability. So this indicates to us that there are other factors not accounted for in this model that could possibly enhance predictability of life expectancy. So this ends this second part of our multiple regression analysis video.